Hi everyone and welcome to today's session. Now I'm really excited because what we're going to be having a look at is some of the management strategies for reducing the risk of tectonic hazards. Now we're going to focus on two in particular today, and the two that we're going to be having a look at are monitoring and prediction. So they're quite interesting in the sense that we're going to have a think about whether volcanoes and earthquakes can be monitored in the same way. Now, all you will need for today is a pen and a pencil and a piece of paper. And then can I please ask, as usual, turn your phone off, make sure that you're somewhere where you won't be disturbed, and let's go and have an amazing session. Okay, so let's make a start. So as I say, what we are going to be having a look at today is how we can use monitoring and prediction to reduce the risk of hazards. So the first thing that I'd like you to do, please, is to write the title and underline it. It's also a question, so make sure that you include a question mark at the end. And then let's make a start. Okay, so there are in fact 4 strategies that we can use to manage hazard risk. And those 4 strategies are monitoring, prediction, protection, and planning. Now, today's session, we are going to focus entirely on monitoring and prediction. And then in our next session, we'll have a look at protection and planning. Now, essentially, management strategies are put in place to try and reduce the effects of natural hazards. So they try and reduce the number of deaths, that people get injured, they reduce homelessness and unemployment. That's the aim of these management strategies. Now, what I would like you to have a look at before we get started is this image of some volcano monitoring. Now, volcanoes are monitored all around the world because volcanoes that are active are incredibly dangerous to the people that live near them. Now, we're going to look in a little bit of detail about what all that equipment is, what it does, what role it plays in keeping people safe. But the idea behind monitoring is that actually it allows us to keep track of what's happening. And then that can be used to help warn people, should they need to be warned, so that they can take action to minimize those risks. Okay, so what I would like you to do is to have a look at this list, and I want you to decide which 2 are management strategies for tectonic hazards and which 2 are actually responses to tectonic hazards, so something different. Okay, so hopefully you have said monitoring is one and prediction is another. So charities providing aid and roads being rebuilt, they are what we call responses to natural hazards rather than management strategies. Okay. So when we look at volcanoes, all active volcanoes in the world are monitored. And essentially what scientists do is they monitor the volcano for some signs that can indicate that an eruption is about to take place. So there are 3 major things that those scientists are looking for: ground deformation, escaping gases, and seismic activity, which essentially means small earthquakes. Now, what I'm going to ask you to do in a second is to draw a diagram of a volcano and then to annotate onto that diagram these monitoring strategies. But I want to tell you a little bit more about each in just a second. So what we're going to do now is this. I'm going to ask you to draw an annotated, I suppose, sketch really of Mount Fuji, which is in Japan. Now, Mount Fuji is a really important volcano for several reasons. So one, it erupts from time to time. The other thing is that Mount Fuji is only 100 kilometers away from Tokyo, and Tokyo is one of the world's most important cities in terms of finance. The other thing is that there are 750,000 people that live at the foot of Mount Fuji. So it is really, really important that it is monitored really carefully, because if Mount Fuji erupts, they need to evacuate those 750,000 people at the foot of the volcano. But it can also have significant effects on Tokyo, which has a huge number of people flying in and out on a day-to-day basis. So they often would have to close the airspace to make sure that the aeroplanes aren't damaged and that nobody is hurt. So the way that they monitor this volcano is in these three ways. So the first way is that they look for something called ground deformation. Now, ground deformation essentially means that the land changes shape. So what they do is they have lasers mapped out across the whole of the surface of that volcano. And if part of the volcano begins to bulge or it changes shape, what that can signify is that magma has made its way into the main vent of the volcano, and there could potentially be an eruption. So that's the first way that they would monitor it. Now, the second thing is that there is a team of people that monitor Mount Fuji, and they collect volcanic gas samples. Now, volcanoes are always giving off gas. There's always some kind of gas or potentially ash coming off the top of a volcano. But what those scientists look for is changes to the concentration of carbon dioxide and sulfur dioxide. Because if the concentration changes, then that can signify that there is more magma and lava at the surface and an eruption is about to take place. The last thing is that actually they have 800 seismometers across Japan. And essentially what they do is detect and locate what we call seismic activity. Now, seismic activity is essentially small earthquakes. So what they do is that they monitor those small earthquakes and look for changes. And if there are any changes, then actually that can signify that an eruption is about to take place. Often just before an eruption, there is a huge number of small earthquakes that happen. So what I would like for you to do, please, is this. Could you pause this video and sketch out a beautiful diagram of a volcano, and then add these three strategies for monitoring it around the outside? Now give it a title, and again, the title is Mount Fuji in Japan. And then when we come back, I'm going to ask you some more questions. Okay, so what I'd like us to do now is to use the information that we've got to actually fill in the gaps. So I'm going to read this to you now. The answers that you need are at the bottom, and your job is going to be to write this out and to put the correct answers in the correct gaps. So there are 750,000 people living at the foot of. It is very important to monitor the volcano, and this can be done in three ways. The volcano is monitored for, if the size and shape of the volcano changes, it can indicate an eruption. Number two, change to gases such as carbon dioxide and can indicate an eruption is about to take place. And then last but not least, measure small earthquakes which can indicate that a volcano is going to erupt. So pause your video now and we'll go through the answers. Okay, did you get? So there are 750,000 people living at the foot of Mount Fuji. It is very important to monitor the volcano, and this is done in three ways. The volcano is monitored for ground deformation. If the size and shape of the volcano changes, it can indicate an eruption. I think that's quite nice because carbon dioxide and sulfur dioxide, it's just two words that you need to change, can indicate an eruption is about to take place. And then seismometers measure small earthquakes, which can indicate that the volcano is going to erupt. Now, I like this word because I think it's funny to say. So I want you to practice saying it after me. Seismometer. Say it again. Seismometer. Good. Now, a seismometer, I'm going to show you in our next session, and it actually, as I say, it measures small earthquakes. Right, give yourself a tick for each of those answers that you got correct. Give yourself a tick. I just told you to do that. Highlight where you've got each of those answers correct, and then let's move on. Okay, so we've had a look at the fact that volcanoes can be monitored and in actually lots of different ways. And we can use that monitoring to then help us to predict that a volcano is going to erupt. But my next question is, can we monitor earthquakes in the same way? And the answer is, truthfully, no. Now, these seismometers that I was talking about earlier that they use to measure mini earthquakes and therefore can then predict volcanic eruptions from, seismometers can be used to measure, what we would call irregular tremors. Now, those tectonic plates are moving constantly. So actually, seismometers are measuring constantly that movement. But if the pattern changes, that can indicate that there is an earthquake about to happen. However, it's not reliable. It's not always the case that if there is an irregular tremor, that there is going to be an earthquake. So it's really, really difficult to use that as a monitoring strategy. Now, the other thing that we can do is monitor animals. Now, I want you to have a look at this beautiful photograph because this is my dog and this is Ernie. And essentially, what can happen is that animals' behavior can change just before an earthquake is about to happen. But again, it's hugely unreliable. In 1975, they actually were able to predict an earthquake based on animal behavior in a zoo, but ever since then, they've not been able to do it reliably. So actually, unfortunately, it's not a reliable method. So while we can monitor volcanoes and then use that monitoring, to then predict that a volcanic eruption is going to happen, it's not the same with earthquakes. So what I would like you to do now, please, is this. I've got three statements. Excuse me for a sec. I've got three statements. Animal behavior can accurately predict earthquakes. Seismometers can detect small earthquakes before volcanic eruption. And carbon dioxide and sulfur dioxide are gases released before an earthquake. What I'd like you to do is just to decide which of these are true and which of these are false. So pause the video now, read the statements again, write them down, true or false. Okay, so let's go through the answers. So animal behavior can accurately predict earthquakes. That is not true. So they can in some cases, but it's not an accurate way to predict an earthquake. Seismometers can be used to detect small earthquakes before a volcanic eruption. That is true. So we can do that. We can see that there are mini earthquakes taking place, and that can indicate a volcano is about to erupt. And then last but not least, we've got carbon dioxide and sulfur dioxide are gases released before an earthquake. They're not. This was a sneaky question. They are gases that are released before a volcanic eruption. Now, I expect I caught several of you out there, and if I did catch you napping and not reading it as carefully as possible, then that is a life lesson to make sure you always read questions properly to make sure that you are 100% accurate, because I guarantee you would have all known that. Okay, so now we're going to have a think about whether volcanoes and earthquakes can be predicted, the second of our management strategies. Now, volcanoes, absolutely. The reason that we're able to predict whether a volcano is about to erupt is because they are monitored so closely. And what that actually allows is for people to evacuate. If they think a volcano is going to erupt, warnings can be put out, and then residents can leave their homes. Now, this is really important. And actually, as I say, it helps because the monitoring is so good of all the volcanoes in the world. Now, the issue with earthquakes is that they can't be reliably predicted. we can focus on where they'll occur, but not when. So if you have a look at our map that you saw earlier on in one of our lessons, this shows earthquake belts and where recorded earthquakes take place. And you can see that the majority of earthquakes take place on those earthquake belts. However, there are anomalies. There are earthquakes that take place in different places that aren't on those belts. And actually, as I say, it's very, very difficult to monitor and then to predict that an earthquake will happen. Now, if you want to, pause the video now and take a note of both of those things. Okay, so what I would like you to do now is to look at the 4 statements that are on the screen, and I would like you to decide which of these statements is true. So 2 of them are true and 2 of them are false. So we've got earthquakes can be predicted, so people can be evacuated when there is one due to happen. Then we've got animal behavior and seismometers can predict earthquakes, but the methods are unreliable. Volcanoes can be predicted due to careful monitoring. Volcanoes cannot be predicted accurately. So have a really good think which of those 2 statements is true. Okay, so I am hoping that you have said animal behavior and seismometers can predict earthquakes, but the methods are unreliable. And this one. So volcanoes can be predicted due to careful monitoring. Now that is true. So actually, in a way, it's better to live near a volcano than it is to live in an area that might suffer from an earthquake, because at least if there is a volcanic eruption, most of the time you can predict it. Right, well done. We are almost at the end of the session, but I've got one more thing I want you to do. So I want you to pause the video in a second and to answer this question. So describe how volcanoes are monitored so that people can prepare for an eruption. So success criteria. Now, this is just to help you formulate your answer. You could use the following key terms. So ground deformation, gases, and seismic activity. You may not want to talk about all 3 of them because if you notice, this is only a 4-mark question. So if I were you, I would talk about 2 of the different strategies that that explain how volcanoes are monitored, but I wouldn't talk about the last one because you don't need to. So you're going to make 2 well-developed points. That's what I was just saying. And then what I want you to do is to link the monitoring to the action that could be taken that would help save lives. So what is it about a seismometer that actually allows people to take action? What action would they take? So pause the video now and we'll come back in just a second to go through the answers. Okay, so well done for doing that, and let's go through the answer. So volcanoes are closely monitored, which can give people a warning that an eruption is going to take place, which gives time for them to evacuate. Now, that's the key thing here, is that if we monitor volcanoes, we can then predict them, which means that we can then take action to manage that situation. So one strategy for monitoring a volcano is using sensors to detect ground deformation. And I've given myself 1 mark there because I've named one of the strategies. Changes in shape can mean the volcano is going to erupt, indicating people may need to evacuate. So then the reason I get the mark there is because I've gone on to say that there's a change in the shape. I've essentially told the person reading this what ground deformation actually means. Then the second paragraph. So another strategy for monitoring volcanoes is that gas meters can measure changes in carbon dioxide and sulfur dioxide. Give myself a mark because I've not only said that there are gas meters that can measure those changes, but I've also said carbon dioxide and sulfur dioxide. So I've been really specific and not just said, oh, there's changes in the gas. Because again, if I know it, add it in. Then I've said, if the concentration of gas changes, it can indicate an eruption will take place. So what I'm going to ask you to do now, please, is this. I would like you to do exactly what I've done in my answer and go through and highlight any of the key terminology. So really important bits of information. And then what I would like you to do is to mark it. So give yourself a tick for each point that you've made and then developed in your description. Okay, well done. We are nearly there. Okay, so that brings us to the end of another amazing lesson. I am really proud of you and well done for sticking with it this far. So what we looked at then was monitoring and prediction. And I think if we were rounding up this session, what is really important for you to walk away with is this understanding that volcanoes can be monitored reliably and can therefore be predicted. Whereas in comparison, earthquakes can be monitored, but it isn't reliable, and therefore it makes the prediction of earthquakes much more difficult. Now, what I'd like you to do, good practice as ever, go back through your work, make sure that you highlight anything that you've learned today that you think is mega important, and then I look forward to seeing you next session. Well done. Bye.